Hi physics. So this is from homework 4. This is problem 4. We've got Charlie and Denise moving a couch. We know that mass. We know Denise is pulling with a 200 Newton force at an angle of 40 degrees above the horizontal. So that's going to be a little bit weird. Mu sub k, which is the coefficient of kinetic friction between the couch and the floor, is 0.200. And we want to know two things. We want to know we want to know what is the normal force on the couch. So that's the normal force from the ground on the couch. So F sub n is equal to question mark newtons. And B, how hard must Charlie push to keep the couch moving at a constant 1.0 meters per second? So we want to know how hard must Charlie push. So that's F sub c, force of Charlie, is equal to question mark newtons. So on to step 1, which is sketch. So again, all year long, step 1 is always make a sketch. So what do we have here? We've got the ground, we've got a couch. So you may notice this couch only has 2 cushions. So I would call this a love seat technically, but just go with it. It's a couch. We know the mass of this couch is 158 kilograms. We know that Denise is pulling with a 200 Newton force at an angle of 40 degrees. So this is going to be a little tricky. So she's pulling, but she's not pulling straight to the side. She's pulling at this angle. So let's imagine she's got some kind of string for some reason she's pulling with. And we know that this angle here is equal to 40.0 degrees. So here is Denise. She's pulling on like that. And F sub d is equal to 200 newtons. Now Charlie is pushing, so he's helping, he's pushing from the right. So here's Charlie. And F sub c, how hard is Charlie pushing? We don't know that. That's one of the things we're trying to figure out. So F sub c is equal to question mark newtons. Let's see, what else do we know? We know the coefficient of kinetic friction, mu sub k, is equal to 0.200. We know the couch is moving, so let me give the couch speed lines. So technically everyone's moving, so everyone gets speed lines. And what else do we know? We know that the couch is moving at a constant 1.0 meters per second squared. That's going to be important. So 1.0 meters, I'm sorry, I think I may have just misspoke. A constant 1.0 meters per second. So what kind of thing comes in units of meters per second? So we know this whole thing is going 1.0 meters per second. Those are units of velocity. So v is equal to 1.00 meters per second. The fact that it's going at a constant velocity tells us something very important. That tells us that the acceleration in the x direction is actually 0 meters per second squared. So what kind of number, what do we do with that v equals 1.00 meters per second? What kind of number is that? That is one of these kinds of numbers. That is a red herring. That seems like very important information. What's the velocity of the couch? But velocity doesn't have anything to do, it doesn't come into a force problem. So that number is actually just there to distract you. The important thing is that the velocity is constant. Constant velocity means that acceleration is 0. What the velocity itself, what that number actually is, turns out that doesn't matter. So that's important. That's going to come up later. So we've done step 1. On to our free body diagram. Sorry, let me make a new page here. So free body diagram. So step 2 in a force problem is always this. We have to turn let me get to the right page of my work. The couch is now a box. So here's our box. And we have to attach all of the forces to this box. So what forces do we have? Let's see. We know the couch is on Earth, so there's a force due to gravity. The couch is touching the ground, so that means there's a normal force from the couch on the ground. The whole thing is going to the right, which means friction between the couch and the ground, F sub k, the force of kinetic friction, is going to be to the left. We know that Charlie is pushing to the right, so force of Charlie is going like that. And then what about the force of Denise? So that's not going exactly to the right. That's going at some angle like this. So this is some angle. So force of Denise is going like that. So if you look at this free body diagram, this is correct, but we've got a problem. We've got an ugly vector. The force of Denise, it's not doing one thing, it's doing two things. It's going to the right and it's going up. So that's a problem for us. Just like when we were doing the kinematics problems, whenever you get an ugly vector, what you want to do is find its components, which I call step 0. So we need the components of this. So it's 40 degrees. 40 is less than 45, so when I draw this, I'm going to be careful. And I'm going to make sure I draw something. F sub d is equal to 200 newtons. I'm going to make sure that the angle I draw this at, theta, is less than 45. So 40.0 degrees. That'll be helpful in a minute. I'll show you why. So I can't work with this vector. I want to find out what are its components. So how much of this is going to the right? How much of this is going up? So the part of Denise's force that's going to the right, I want to call that F sub dx, force of Denise in the x direction. The part of this force that's going up, I want to call that F sub dy. So now I've got to look at this guy, and I've got to figure out a couple of things here. So if I'm looking at this triangle, all right, well, this is a right angle. So OA and H, which side is which? So F sub d, that's the hypotenuse. That's the biggest side of my right triangle, so that's got to be the hypotenuse of this right triangle. F sub dx, is that O or A? That's the side that's adjacent to the angle that I'm going to work with. So that means this one is A. F sub dy, that's got to be O. That's the side that is opposite the angle I want to work with. So that's going to be useful when I'm figuring out what these components actually are. So F sub dx, that's going to end up being F sub d times some trig function of theta. So I'm going to skip through it kind of quickly. This is the adjacent side, so which of the trig functions uses the adjacent side? Cosine. Cosine is A over H. So that's going to end up being F sub d cosine theta. And F sub dy is going to end up being F sub d times some trig function. Which is the trig function that deals with the opposite? That's going to end up being sine. So sine of theta. So now I'm going to put in my numbers and figure out what these things actually are equal to. So F sub dx is equal to F sub d, so 200 newtons, times the cosine of theta. Theta is 40 degrees. And if I do that in my calculator is going to tell me that F sub dx ends up being 153.2 newtons. And I'll circle that because that's important. If I go over to F sub dy, so that's equal to F sub d is 200 newtons times the sine of 40 degrees. If I ask my calculator, what does that end up being? F sub dy ends up being 128.6 newtons. and I'll circle that because that's going to be important too. So quick, do a mini step, I'll do this in orange. I want to do my small, medium, large test just to make sure I did my trig correctly. So which of these sides is the smallest? That would be this guy, and that's my smallest number. Which side is medium? That's this guy, that's my medium number, and my large number is 200. So the numbers I have end up matching my triangle. That's why it's very important that when you draw your triangle, you draw your angles correctly. 40 is less than 45, so I made sure that I drew it as less than 45. I don't need to get out a protractor and do it exactly. I just need to get it close because that lets me do my small, medium, large check. So that works, so I'm happy. So one more little thing we can do from here. Now we're going to do step 2 again. But this time we're only going to have pretty vectors in this thing. So let's start with the box again. And all the vectors that were already pretty, we get to keep those. So f sub g, that was fine. F sub n, that was fine. F sub k, no problem with that one. F sub c, 4 sub Charlie, that was already going to the right, so that works out fine. But now instead of drawing the ugly vector f sub d, I'm going to draw in the two pretty components that I just figured out in step 0. So I'm going to end up with something going to the right, that's f sub dx, and my other component, f sub dy, was going up. So now I have f sub dy. So now I have another free body diagram, but the important thing is that this free body diagram only has pretty vectors. So that means I can work with this one. I couldn't work with the first one. So let me quick sum up this part and then I'll stop this video because I don't want it to get too long. So what do we actually do here? Just like usual, we start out with step what are we looking for? What units do we expect it to find? Then we go on to step 1, which is make a sketch. The sketch tells the picture. The sketch tells the story of what's going on. It's a picture of all the things. We have lots of information in the sketch. In the sketch we have velocities, accelerations, masses, coefficients of friction, and we have forces, one of which we didn't know. But you can have lots of things in your sketch. They tell your story. Then we go on to step 2, which is free body diagram. So turn your object into a box, and to the box you only attach forces. So I did that. I ended up with 5 different forces. 4 of them were okay, but one of them was an ugly vector. Just like last chapter, in kinematics, if you have an ugly vector, do a step 0. Do some trig, turn your one ugly vector, which was f sub d, into 2 pretty vectors. One that's only in the x direction and one that's only in the y direction. So I did that, I got my 2 pretty vectors, and the way I recommend doing these problems is after you do step 0, go back and do step 2 again, and this time have a free body diagram that only has pretty vectors in it. So hopefully that helps.